Hello, Mr. Sutton here, bringing you the Pre-Cal Honors 2-2 Part 1 homework solutions on synthetic division. For this problem, we want the remainder, whether the divisor, x plus 4, is a factor of this dividend, and also the quotient. We're going to answer all those questions with synthetic division. So we'll start by writing down the coefficients of our polynomial, our dividend. So we have a 5 for that first one, and then an 18, a negative 6, and a positive 1. And there's no placeholder zeros because we didn't skip any terms. For the box number, we have an x plus 4 divisor, so that means whatever zeros that out is our box number, so negative 4. And now we leave some space, write a line there, and then bring down our first coefficient of 5. This box number gets multiplied by the bottom row, so negative 4 times 5 is negative 20. That goes in the second row. We add the top two rows to get the rest of the bottom row numbers. 18 plus negative 20 is negative 2. Negative 4 times negative 2 is 8. Negative 6 plus 8 is 2. Negative 4 times 2 is negative 8. And then 1 plus negative 8 is negative 7. That last number is our remainder, negative 7. Since that remainder is not 0, that means x plus 4 is not a factor of the polynomial. For the quotient, we're going to use all the numbers in the bottom row except for that last remainder. So that means we have a 5 for the first coefficient of our quotient. That's going to be 5x to the second power, because our quotient always starts one exponent less than our original, because you did x cubed divided by x. So that gives you an x squared there. And then this negative 2 represents negative 2x, and then this 2 is really just a plus 2. To set up the synthetic division on this problem, we'll write down our coefficients of our polynomial. So we have a 3 for the x squared, followed by 11, and then a 10. Since x plus 2 is our divisor, we're going to have a box number of negative 2, because that would zero out that parentheses. And then we do a little line with some space, and bring down our first coefficient of 3. Now we multiply negative 2 by all these bottom row numbers and put them in the second row. So negative 2 times 3 gives us negative 6. And then we add the first two rows. So 11 plus negative 6 is 5. Negative 2 times 5 gives us negative 10 in the second row. 10 plus negative 10 gives us 0. So this is our remainder of 0. Since we have a remainder of 0, that means that x plus 2 is a factor of our polynomial. So our quotient then, we're going to have 3x, because it's one exponent lower than we started with. We did an x squared divided by an x. So we have a 3x plus 5. For this problem, we want to find the remainder and all that other stuff. So let me use synthetic division for this. I'll start by writing down my coefficients for this quadratic. So we have an x squared giving me a 1 for that first coefficient, invisible 1. Then a negative 8 for the x, and a positive 15. No placeholder zeros because I didn't skip any terms. Our box number is going to be whatever zeros this x minus 3 out, so positive 3. Leave some space, draw a line. Bring down your first coefficient of 1. And then we multiply our box number by all these bottom row numbers that are going to be down here. So 3 times 1 gives us a 3 in the second row. Add the top two rows to get the rest of the bottom row. So negative 8 plus 3 is negative 5. 3 times negative 5 is negative 15. And 15 plus negative 15 gives us 0. That 0 is our remainder. The last number down there is that remainder of 0. And that means that since we got a 0 remainder, x minus 3 is a factor of x squared minus 8x plus 15. So yes, it's a factor. Our quotient is going to be these two numbers down here that are not the remainder number. And we're going to start one exponent lower than we started. Since we started with an x squared, that means our quotient starts with an x, because you have an x squared divided by x. So this 1 really means 1x. And then we have a minus 5. That's just the constant minus 5. On this problem, we're trying to find the remainder by dividing, and we're going to use synthetic division. So let's see here. We've got our coefficients of our polynomial that we have to write down. So we start with this 2 right here, followed by 11, 9, and we're checking to make sure there's no skips in our exponents, but we're going 4, 3, 2, 1 for the exponent here. So our next one is negative 14 for that coefficient, and then negative 8. So no placeholder zeros here. We didn't skip any terms. For our box number, it's whatever zeroes out our divisor, so that's going to be -3. And we'll leave a little room, do a line, and we'll bring the 2 down to the bottom here. So the first coefficient gets brought down automatically. We multiply our box number by whatever's in this bottom row and put it in the second row. So -3 times 2 is -6. And now we always add these top 2 rows. 11 plus -6 is 5. -3 times 5 is -15. 9 plus -15 is -6. -3 times -6 gives us 18 in the second row. -14 plus 18 is 4. Times -3 gives us -12. And -8 plus -12 gives us a last number here of -20. So we have a remainder then of -20, that last number. Since that's not 0, this means that x plus 3 is not a factor of the bigger polynomial. And for our quotient, we're going to have x cubed as our first term, because we started with x to the 4th and divided by x, so it's one exponent lower. So we have a 2, this here is our coefficient, 2x cubed plus 5x squared minus 6x to the first, plus the constant 4, and that's it. To divide this big polynomial by x minus 1 and answer the question, I'm going to use synthetic division. So that means I begin by writing the coefficients of the polynomial. So we have a 1 for the 1x to the 5th, followed by a -3 for the x to the 4th, and a 2 for the x cubed. We have a 5, a 4, and then another 4 for the constant. For our box number, we're going to use 1, because that zeroes out our divisor of x minus 1. Leave some space, draw a line, and then let's bring down that first coefficient of 1. We multiply our box number 1 times all the bottom row numbers to get the second row. So we have 1 times 1 is 1. -3 plus 1 is -2. And we have 1 times -2 giving me a -2 up here. And I forgot to mention here we're adding those top 2 rows to get the bottom row now. So 2 plus -2 is 0. 1 times 0 is 0. 5 plus 0 is 5. 1 times 5 is 5. 4 plus 5 is 9. 1 times 9 is 9. And 4 plus 9 is 13. That last number, 13, is the remainder. Since that's not 0, that means x minus 1 is not a factor of the polynomial. And then for our quotient, we have an x to the 4th as the highest term because it's always 1 less than you started with. X to the 5th divided by x is an x to the 4th. And for the coefficients, we're using these numbers down here except for the remainder. So this 1 represents 1x to the 4th in the quotient. This -2 is -2x cubed. This 0 is the x squared term, but we're not going to write 0x squared. We're just going to leave that out. This 5 is really plus 5x. And this 9 gives us a plus 9 for our constant. On this one, we're trying to find the remainder, also whether 2x plus 5 is a factor of this big polynomial, and the quotient from doing all this. I'm going to use synthetic division to make this happen. So let me start with the coefficients of the polynomial. We've got a 2 for the 2x to the 4th, minus 9, minus 23 for the x squared, plus 36, and a positive 5 for that constant. So no placeholder zeros because they didn't give us any missing terms. Now for the box number, that's a little trickier. It's going to be whatever zeroes out this divisor. So if I set 2x plus 5 equal to 0 and solve, I would have to subtract 5 and then divide by 2. So -5 over 2 is going to be my box number. Now let's leave some space and draw a line. Bring down our first coefficient of 2. I'll multiply this box number by the bottom row to get all the second row numbers. So -5 over 2 times 2. The 2's are going to cancel, leaving us with -5. Now I add the top 2 rows to get the bottom row. -9 plus -5 is -14. Multiplying that by -5 over 2, well, 14 divided by 2 is 7. -5 times -7 gives me 35. -23 plus 35 is 12. Now 12 divided by 2 is going to be 6 times -5 is -30. 36 plus -30 is 6. 6 divided by 2 is 3 times -5 is -15. And then 5 plus -15 gives me -10. That -10 is my remainder. Since that's not 0, it means that 2x plus 5, after all that work, is still not a factor of this polynomial. And for the quotient, That's going to be all these numbers down here except for that remainder of negative 10. So 2 is the first coefficient of our quotient, and we're going to start with an x that has an exponent 1 lower than the original. We started with x to the 4th, so now x to the 3rd is what we end up with down here, 2x to the 3rd. And then this is minus 14x squared plus 12x, and then plus 6.